This video is about carbide tips in the home workshop. And right from the beginning, I'm going to tell you that I'm not going to tell you about buying a specific tip for a specific job for a specific tool. Because let's be honest, we're not in a production tool room, and if we were, the rep would come and visit us and take us out for coffee and play golf and woo us to buy whatever tip he just happened to have available. The thing is, in the home workshop, we don't have that luxury. We actually need to work hard for the tips that we buy. And even if you do get them for free, you want them to last as long as possible. The thing is, there's far more to these little guys than meets the eye. Let's just take this little one for a good example, right? If you have a look at it, sort of standard, you would say, okay, it's got 3 cutting edges because it's got the rake to the left. It's a left-hand tool. It's got quite an aggressive rake over there, so this is probably for aluminium. And in a commercial workshop, you would have 3 cutting edges, and that would be it. But in the home workshop, this little guy can do a whole lot more. For example, yes, it has the 3 cutting edges with a high rake for aluminium, and that'll do just well. But if you flip it around, like so, now you have a finishing tool, and it's also perfect for sort of the brasses and the plastics and so forth. And then when you're done using all 6 cutting edges of a tip tool that was originally only 3, then this can be brazed onto something else and reused again and again and again. Incidentally, these things don't really want to be thrown away because, well, let's be honest, that's throwing away money and it destroys the trash compactors. And besides, these things can be used over and over and over again. So this video is going to show you how to do that. But let's just start with this little guy and let's just prove my initial statement that there are far more ways to use this specific tip than meets the eye. Alright, so let's take this rather bold claim that I made at the beginning of the video and let's test it. So this tool is typically used for cutting aluminium. It's got a heavy rake, but it'll work just fine on mild steel. And in the home workshop, look, tools need to do different things. So it can take quite a deep cut on mild steel. The problem is the lighter cuts are slightly more difficult. Because the cutting edge of these tools have got a radius, and all that radius does is it extends the life of the tool, it is limited by the depth of the cut. So in a case like this, and on this tool, you can't really cut more than a 0.2 of a millimeter. But if you flip that tool around, now all of a sudden you can do much finer cuts. And because you're doing finer cuts, it's more of a finishing cut, so you get a much better sort of surface finish. In this example, I'm machining down a shaft for a wheel in one of my projects. So I'm looking for a very close bearing fit. The idea is to get lubrication in between the sort of wheel bearing and the shaft itself, but you want a very smooth and clean surface. The smallest cut that I'm doing sort of towards the end is between 10 and 15 micron. And that's typically what you're looking for with a bearing fit clearance. You can actually see when it's cutting the difference between the very, very fine cuts and the previous cuts. The surface is a lot shinier, it's a much cleaner cut, and you don't get any of the waves that you get when you're using the tip tool on the other side. Also, because the other side of the tool has got a much rounder cutting edge, again, you get a much cleaner surface. And now if you take that wheel, it fits fantastic. Yep, that'll do quite nicely. I am very fortunate to have one of these small little tip tool sets from my favorite tool supplier. And I'll put the link to these sets in the description. They actually have a few of these sets and they work really, really well. The interesting thing is this set costs less than a single industrial high-end tip. And you know what? They work just as well. I've gotten very good life out of these tools and the tips last long. I'm very, very happy with it. One of the youngsters asked me, sort of, when do you use what tip for what application or what tool for what application? And the answer is actually not that simple, but I can give a couple of guidelines. If you have a look at a tool like this is in industry they typically use as a grooving tool, And in heavy industry with the lathes with large power, they just plunge in and they do whatever they need to do. But the home workshop, the motors aren't that strong, so the power requirements are a little bit heavy for the home workshop. In a case like that, you sort of need to do this action from left to right. And that gives a clue on pretty much every tool and how it's used. And the clue is this: you only use one side of the tip at any one point. You never want to plunge in, because then you're using both sides and you're actually creating a wedging action. And that more than doubles your power requirements on a lathe. Also, the problem is the chips tend to clash with each other because you've got a chip coming in this direction and a chip coming in that direction. So it's just a big mess. The minute that you understand that simple concept, now all of these tools become easy to understand. This one, you can groove like this. You can go to the left, go to the right. And then every other tool becomes clear. This is a left-hand tool, and you can also use it as a facing tool because it's got both sort of surfaces that'll be perfect for the job. Another interesting thing is if you have a look at this tool and you have a look at the facing or left-hand tool, the tip radius is a lot different. So this one will give you a much better finish because you're cutting sort of on a radius, a larger radius. So the amount of material that you're moving off is over a larger area, where this is a much smaller area, so you tend to get a less of a nicer finish. Another thing to look out for when sort of getting your tips is what the chip breaker and the rake looks like behind the cutting edge. So if we compare that first example that I had right at the beginning of the video and you compare it to these tools, you can see the chip breaker and the rake is very, very different. Now that first example is typically sort of more of an aluminium cutting tool. You can see it has quite an aggressive rake and it has a large chip breaker. Now that large sort of rake and the large chip breaker is to stop galling or cold welding that aluminium is particularly bad for. Actually, here's a little tip, right? If you're cutting aluminium, one of the best cutting fluids for aluminium is paraffin. And what you can do is you can mix a tiny little bit of lubricant with the paraffin. If I have lathe spindle oil left, I typically add between 10 and 20% to the paraffin. If I don't have that, then I add about 40% diesel. And you end up with a beautiful cutting fluid. And you just add it on with a brush and you don't get any galling on your tip. A tip like this with a short chip breaker and not an aggressive rake, you're going to end up with a lot of galling. So the aluminium is going to stick to the tip. So this tip is far better suited for cutting aluminium and the softer, high galling materials like copper, aluminium, and so forth. Where this one works a lot better for the stainless steel and the mild steel. But like I showed in the video, this tip will work just as well with aluminium, so they are interchangeable to a large degree. And in the home workshop, you would typically do that because not everyone is fortunate enough to have multiple tips. This chip breaker behind these sort of cutting edges is actually quite important. What it does is it forces the material coming off of the tool to curl, and that's actually a safety thing. You want your chips to curl and you want them to break so that you don't end up with long strands that become very dangerous. Unfortunately, there's one place where you're going to fall short with tip tools, and typically it's with boring bars. They just seem to never be the right size. They're always too short or too small or too big, and I've always had an issue with them. So one of the nice things that you can do with your boring bars, or specifically with used tips, is you can silver solder them to a piece of bar. And in this case, this is just normal mild steel because it's quite a thick bar. And it is silver soldered to a corner that I've ground off. And all that you do is you take the angle grinder and you cut a piece like that. You cut a piece off so that you make a nice step. And typically you want it more or less in the middle of the bar. And then you just silver braze the tip onto that corner. And when I say silver braze, typically I use about a 20% silver, which is the cheaper version, but the 35% silver copper brazing alloy tends to work really, really nice for brazing these tips onto mild steel. This little bar has made a number of chimneys for a number of my builds, and it works really, really well. So if you find yourself short on the boring bar, you can use your old tips and braze them onto a piece of bar like this. The only trick that you sort of get stuck with is how to sharpen these tips. And there's a very simple way of doing that without having to sort of spend a lot of money on diamond cutters and all sorts of stuff like that. So most people with a home workshop will have one of these bench grinders. They work perfectly for sharpening drill bits and any high-speed steel. The problem is these wheels are not suitable for carbide tips. They're just too hard. It's a bit counterintuitive, but you actually want a green soft wheel for your carbide tips. The problem is the industrial carbide wheels that you get won't fit the standard half-inch shaft on these bench grinders. These are typically 32 millimeters, so what you do need to do is you need to make yourself a nylon spacer, and then that will slip over much better on your shaft. You do need to make sure that the clamping washer completely misses the spacer and clamps on the sort of cardboard on the outside. That's very important, and you can't remove this cardboard. It's actually there for a reason. And then a simple thing to remember is the left hand wheel is the opposite. So lefty is not loosey and righty is not tighty. It's actually the opposite way. So if you change one of these wheels, it is the opposite way. And this will grind a carbide tip perfectly.